Okay, for assignment 2, the first question, right? The first question requires you to find the G prime of 2. How do you find the G prime of 2? Okay, for this question, right, to find G prime of 2, you have to use the so-called quotient rule, right? It says V du, okay, this du, you got very careful, no? Minus u dv dx. And then this is going to be 2 square. So I think you didn't differentiate correctly.
Yeah.
I think.
I forgot that it's quotient rule. Is it like
Yeah. You went to use operators, right? So the answer for this question is 2 marks. And the answer is also 2, no? I remember it's 2. So if the method is correct, which means you try to differentiate using quotient rule, but you plug it in wrongly, you get 1 mark, at least for method. If you get method correct and your answer is also correct, you get 2 marks. That's how this question 1A is graded. So you want to check your friends working to see that the differentiation is done correctly. There are others who actually differentiated gx separately first. They do the usual way first, means you differentiate this one first. Then minus fx cubed. There are people who do this one first. Then after they plug in the value 2. It's also okay. Right? In fact, you're encouraged to do it this way, you know. But otherwise, if you do it this way and you get the numerals correct, it's just as good. Okay. I really hope that you check your friends' work carefully and give a score. No? Give a score. Okay. The next thing is there a value C such that this happens? So to answer this question basically is trying to use the Rolle's theorem, right? Rolle's theorem. Now, to use the Rolle's theorem, you must first and foremost, establish that it is so-called continuous and differentiable. Now, if your friend's solution is that he or she simply says the function is differentiable on R, and therefore it's continuous on R, and therefore draw the conclusion, like no marks, you know. Because for this question, we really want you to confine to the interval that you're using. You should really say again, this question, right, is to say f is continuous on the specific interval and f is differentiable. Some people say, Mr. Lim, isn't it obvious? Just that we want you to state the precise condition used in this context. So you must say the correct interval. So then by RT, you cannot. We want to be a specific interval. Yeah, a special interval. Right. You must specify the specific interval you're using. So if your friend says R, right, just differentiable and continuous on R, 0. Done 0 again.
Yeah, because before R then it's open bounded. Because open bounded. So then I is open and closed bounded.
It can be open or closed bounded. Gyro verified that minus infinity to infinity is both, you know. So remember, to use RT, right, you want to really specify the specific interval. In the next question, part 2, right? Okay. How do you do this question? Is 1 over what is f inverse of -2? In this case, you're very careful, no? Because your interval is 1, 8, right? Your f inverse 2 must come from here, no? So that f inverse 2 becomes 2. And therefore, this gives you 1/3. Okay? Okay, so check your friend's book and make sure you give him or her that 1 mark each. You know? Okay, show you a work done by one of you. Let's comment, you know, let's comment. Wait, this is correct. Okay, let's comment on the work done.
What do you mean on
this differentiation is even it's done using L'Hopital, no? It's done using L'Hopital, but it's wrong because apart from differentiating f prime, you must also differentiate the. If you do it wrongly, you still need to times the 3x square. 3x square. Okay. So this okay. So like this, right? Like this is 1 mark and 1 mark, and this actually 0/2. So maybe you can make a mark like this, no? To give a friend a score. This is a pen, this is a pen. Okay. Question 2. Okay, for question 2, right? For question 2, part 1. F is continuous at x equals 1. How do we actually prove or find the value of c? Okay, you gotta say this, no? Since f is continuous, we can say that the limit as x approaches 1 plus of fx, right, is equal to f of 1. Now, class, if you write this statement without this line, that because you are making use of the condition of continuity 0, because we want you to write a statement that's supported by reason. Okay, so you must give a reason why you write the next statement. So this becomes limit x goes towards 1 plus. We prefer you write down specifically, that you're using this function. Some people just right away prompt it in, but I prefer you write down which one you're using, is it? So the left hand side becomes just c equals to 2. So that's a part 1. Okay, that's actually part 1. Then for part 2, right? For part 2, okay, so if you do this one correctly, this is 1 mark, so you can put 1 1 out of 1 for part 1. Then next one, right? Next one. Okay, so it's, firstly you say for f to be differentiable, f needs to be right. So this is a very important ingredient. Then you continue and say you want to calculate the left derivative. Okay, for the function to be differentiable at x equals 1, the left derivative, right? The left derivative must be equals to the right derivative. So therefore, to be differentiable, you need 1 point and 2. So for the left derivative, right, you will say its limit x goes towards 1 minus. The left derivative uses which function? The 2 sine pi x over 2. F of 1 is actually 2 x minus 1. And then the right derivative, will be C is 2, okay, C is 2. 2x squared minus ln x minus 2 x minus 1. You can then use the L'Hopital's rule. You use the L'Hopital's rule, right? You will have pi cos pi x over 2 4x minus 1 over x over 1. So you get, actually in this case, right, you get 0 and this is 3, which is not possible. Therefore, f is not differentiable at however, other kind of presentation also works, which means there are people who did not assume that C is 2 yet. They right away went to calculate C and get C equal to half. Yes, Jetro? Top right corner, is it? Yeah, you're right. Yeah, I mean it's like yellow. Wow, I like your coolness, no? What happened? Ishak, what happened? Okay. You walk in very coolly, no panic. You're strolling very coolly. You didn't even greet teacher when you walk in, you know. You did, okay, thank you. Okay, so if your friend done it a different way and then found that C is half, which doesn't tell you the earlier 2, is also okay.
To find that C is half, you need to apply L'Hopital to like this one. Like you don't know that the top is 0, so you can't apply it. Like you do this, and then you apply L'Hopital. But you're assuming that the top equals 0, so you can't apply L'Hopital.
Good point.
So you can't find that C is half.
Good point. So there is a question that's raised, you know. in the absence of the value of C, Yu Tong say is wrong, you know. She say because if you do not know that this is 2, and then you apply L'Hopital's rule blindly, technically she says it's wrong. I think she has a point. Therefore, I got to retract. I think she has raised out a very good point that maybe if C is unknown, we can't apply L'Hopital's rule. Then we are stuck. We are stuck. So therefore, you can roll back and do it this way. That means have to establish that C has to be 2. Okay, so I retract. So that method actually falls apart. Okay, that method actually falls. So that method cannot. If people use the method, let's give 0. Hey, thank you, Yu Tong. You raised a very good point. Yeah. Yes. You didn't assume there was C. Then how do you evaluate the limit? You evaluate the limit how? Okay, let's see. If you don't know the limit axis, right, you can't break the unit. This one to this one. How do you know that this break up this into the difference between the limits, right? For the whole limits must exist. Oh, you okay. Let us now take a look at a piece of work done by your classmates. Let's see. Okay.
It's okay. Don't cry.
Part 1. Let's examine together. Okay. If f is continuous at x plus 1, this must exist, and therefore this is true. Okay. She found the left limit. She got 2. She found the value, and then she went to find the right limit. Okay, let me take this opportunity to tell you something as a marker of a work. Okay, I don't know why. Because it's a take home work, you might want to avoid things like this. But otherwise, it's a perfect part 1. It's a perfect part 1. Let's look at part 2 again. I can't really see this. Okay. Right. Okay, this right. Okay, then she found the. Okay. She found the left derivative. Applying the L'Hopital's rule, she gets 0. That's correct. Okay, this is correct. Yeah, this is a perfect part 2, no. Just that class, because this is a take-home homework, I don't expect to be so, this thing, no. If it can be neater, be helpful, no. Yeah.
What? Because I did it wrongly.
Okay, so she says C does not exist, okay? Right? It's actually perfect, no? The concept is perfect. Right? So for this part, right? For part 1, you say you give a friend 1 upon 1, and then for part 2 is 2 upon 2. Good work. Yep. Just that the cancellation thing, and you want to avoid having too much, of that, You. Sure. You're taking question 1. Maybe I raise all this portion for you, so they just do it that way. Wait, raise all this.
You want to draw the like
Okay. Alright. Question one, okay. Ishan, good. Yep. You don't have the question. Question is wrong, is it? And then?
Imagine drawing the entire
You must have part 1 first. Before you do part 2. Means in part 1 you establish that C has been 2 first. Before you talk about differential means. And then C is 2. You find that out at time 1 doesn't exist. Therefore there's no value of C. Okay. Let's press on with number 3. Generally, when I mark the work from 04, most people can do part 1. Most people can do part 1 quite well, you know. Okay, most people can do part 1 very well. Part 1 is done using L'Hopital's. Let us now look at how we want to present it nicely so that things flow well. So for 3 part 1, limit okay, so part 1, right? You might want to say 0, 0 in indeterminate form. Huh? So because of this, we are going to apply the L'Hopital's rule. So they give 1 minus cosine x, 2x. And it's good that you annotate by the side and say this L'Hopital's rule. Ethan, what do you say?
You say you love me. I say okay, yeah.
Okay, another round of L'Hopital.
Can ask her stop bullying me?
No, I made mistake, no. My eyesight. Sorry, right, I'm bad. Okay, submit. Okay. If your friend has done this correctly, we prefer that you write down that this thing exists and apply L'Hopital's rule, and this thing arrive at 1, 6, you get 1, 1.
Oh.
Right, you should state that it's by the L'Hopital's rule. Without which, I'm quite hesitant about awarding the 1 mark, you know. Yeah, because you're just doing it without giving the reasoning in a minute. We prefer reasoning.
Don't you need to do it one more time?
We did. Just that if as a marker I see that you already know this, I'm okay. You know, if you don't write at all, you know, because see, if you need to use the L'Hopital's rule 10 times, right? Then the question mark is, do you have to write 10 times? I prefer not, because if you have established, if you have impressed upon me that you know when to use L'Hopital's rule, and you actually state the reason for the 1 use of it, down the steps, I assume that you know how to do the same thing like that. So I don't expect you to write 10 times the same thing. I think once will do. Even if it's 5 times, you write it for once, I think I'm okay, because I don't think I want to test you the same thing 20 times.
I wonder how it's supposed to get a function where you have the L'Hopital 20 times. That sounds quite bad, honestly.
I thought the tutorial is something like x per 100 over e power x. You,
but that one you can be.
do you need to write this 0 over 0, is it? It is recommended, so that we know that you know. For the next question, So one approach is to write it this way. Sure. I want to tell that for this question, you could have potentially just bulldoze using the L'Hopital's rule a few times.
4 times actually.
4 times it. Yeah, you can bulldoze it, no? But that's not the intention of the question, no? The intent of this question is for you to mix on part 1.
But they say hence or otherwise.
Right, that's why you can have the otherwise. So one approach is to do it this way, you know. You try to make part 1 show up, you know, by doing a factorization of x minus sine x. And then for the denominator, right? For the denominator, we need x cubed, isn't it? So we're going to make it an x cubed. And then we're going to have sine square x. Because I make an x cubed, I've introduced an extra x. I need to put an x here. Okay, so this question requires you to just so-called rewrite with the hope that the part 1 will show up. And then you can now rewrite the limit as x goes with 0, x minus sine x over x cubed, limit x goes with 0 of x sine x plus 1, then limit okay, and then this one will become 1/6 times 2 times 1. Actually, right, over here you should put a remark, you know, because all the 3 limits exist. Right, you should put a remark. For me to break up into the product of the 3 limits, I should qualify by saying that the limits exist, all the 3 limits. So your friend has done it this way. This one attracts 1 mark, and this one is actually 2 marks.
I think he has kept budget the limits and he won't like it very much.
Let's now look at your friend's book. Oh, sorry. Yes.
Oh, never mind.
Okay, let's look at one person's book.
Oh my god, my brain.
Right. Stating the rule and then applying correctly. This is 1 mark. Yep. Clever. Right. Okay. This portion here, right? This portion here is going to put a brackets now. It's going to put brackets. So over here, instead of doing that way we did, she applied L'Hopital's rule. It's nice that the rule is stated by the side. No? Yeah, it's nice. So you have used the L'Hopital's rule. It can be quite a tedious thing. nice to state that you are making use of the earlier result, is it? This portion here. I don't know why shown now. This question is to evaluate, but it's okay lah. It's alright. It's a good work, a good piece of work. Yep. Okay, that's question 3. Yep. The good thing about doing digitally is if I can't see your words right, I can just drag and then make it bigger. I can see it better. Okay. Okay, number 4. Number 4, right? For the function to be increasing, right? For the function increasing, how do you determine the function increasing? You want to look for the point where the gradient is, right? So looking at this graph, right? It is positive over this portion, and because the function is known to be continuous, so therefore the interval for which it is increasing is -3 to inclusive of -3 and 2. So your friend put rounded brackets, you just take away the 1 mark. Don't have mark. Yeah. If you put rounded brackets, it's 0. It's -3 to 2, inclusive.
Why?
Because this function is continuous, right? Continuous. So imagine for a continuous function from -3 to infinity, and the gradient are all positive throughout. When you draw it right, it will always be increasing from -3 all the way to 2. Notwithstanding that at -3 and at 2, right, it might have 0 gradient, but between -3 and 2, it is always going upwards, because the gradient being positive between -3 and 2. Some people are going to omit 1, The derivative may not be defined, but the function can still be increasing. For example, like that.
Oh, it's not talking about that.
Right, like that. Okay? The gradient may not be defined, but the function is increasing. Right. So therefore, it must be close bracket -3 to 2. Concave up is when the gradient is, and be very careful, whenever you talk about concavity, it must be open interval. For part 2, right? For part 2, I prefer to say that f concave up on -3 and on 3.5 to infinity. I prefer to write the word on twice, because if you do not put on here, right, it becomes on this interval and this interval, right? In math, n means intersection, is it? So it may be misunderstood as this interval intersect the other interval, which means it's a null set. Okay. Then now to draw the graph. You are told that it is 0 at -3. So when you draw the graph, right? When you draw the graph fx, you want to start off with -3 here. I'm going to overlay on the f prime graph in blue color. So between -3 to 1, it has positive gradient, and it's actually therefore increasing. Near 1, right? Near 1, the gradient is 1. So maybe it's like that. Okay, wait. Maybe it's like that. Okay, my upward is not very good. Now be very careful, no? In some word that I mark in O4, they drew the blue curve too straight. It's wrong, you know, cannot. So check your friend's book. If it is too straight, it's wrong. Then in the next section of graph, right? At at 1, right? On the right side of 1, the gradient is 4. So you must draw something steeper. Okay, draw something steeper. And at 2, right? At 2 is a maximum point. So you must draw something that is okay. Luckily, it's digital. I can always erase and redraw quite easily. And then make sure you have a maximum point at 2. At 3.5, right? If it's a turning point on the gradient graph, at 3.5 is actually a inflection point. And the gradient actually approaches 0, which means it will taper towards a flat curve. So when you mark a friend's work, you must have this one shown clearly, 2, 3, 4, and okay, I prefer to drag on a bit more, and 5 to show that the grain tapers towards 0. And then you must mark down the axis flat. It goes flatter and flatter. 6 pointers, okay, 6 pointers. You got very careful, no, class. The word sketch in math is not draw only. Sketch means it must give the technicality in the drawing, the correct sketches. In O4, some of the sketches was really sketch, you know. Really sketchy. I'll award 0 for that. So let's look at this work, okay? Oh, she drew it here, I think. Okay, where is it? Oh, here. Okay. I prefer a shaded circle here. I'm prepared to forgive, you know, without the shaded circle because it's quite clear that she landed there. This is shown. Okay, this one, this portion here, I give the benefit of doubt. Some people purposely put a cross here to tell me there's something there, which I appreciate. I know it. Yep. And then towards the end, yep. And then these are well marked, and indeed there's 0 here, but otherwise it's okay, you know. So therefore, this is 3 out of 3. This one is 0 out of 1, you know. And then this is yeah, this 1 out of 1. This one 2 part 1 is 1. Sure. So what you should do is you can put the subscore against each question. Then after that, let's do our addition, you know. Let's do addition. Okay. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Okay. 13. Okay, I made a mistake, so I got. Okay.
But she minus 3 marks, how is it?
She minus 3 marks, right?
Yeah.
12, right? So 12 is correct, no? Okay, let's redo it. I counted 13 now. Why my math so bad today? Okay, sorry. Let me do it again. This is 0, right? This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Why got 13? Ethan, what went wrong?
I'm not sure.
Well, she deduct 3 marks again. This is deduct 1 mark, right? Or deduct 2 marks. This is deduct 2 marks, right? This 2 marks. Oh, I know why. This B part 1, 2. Okay. 2 part 1. 2 part 2. Oh, I know why. 2 part 2, 2 part 2, 2 part 2, the marks given here, dear. Is it 2 part 2? 2 part 1. 2 part 1. Oh, marks is given here, dear. I given additional mark. Yeah, it's 12, it's 12. Okay, think it's 12. It's 12. Okay. So class, can you write down a score right at the top, you know?
Suffering.
The opening page of chapter 3 is self-explanatory because you all already know about integration. So you know that if the differentiation of big F, is fx, then this big F, right? This big F is called the antiderivative. Or you can just simply say that the integration of fx is just the big F. Something that you already know quite well in your earlier module. And you also know the reason why you need to have a class C. Because the story went this way, you know. If you integrate 2x, right, it's as good as asking, you know, what when differentiated will give you 2x. And you know that differentiating something that gives you 2x can be, and there are many possibilities. So as a way to encompass everything, you realize that you put a C there to represent all these possibilities. And C, in your earlier year, you're always asked to write down that C is an arbitrary constant. Right? Okay, so these are some of the phrases that you are already accustomed to. Be very careful, no? If you are really pure math people, right? I want you to know, no? You will always write this integration together with the differential. No? This symbol actually doesn't exist standalone. Likewise, when you write like this, right? This is a single piece notation. I always refrain from writing just purely dy. Personally, I don't. But I do know that you do. And I do know that the textbooks, some textbooks do. Even our notes do. However, I don't. Because dx, strictly speaking, dx by itself got no definition. But this one has the delta x, delta y, they have a meaning. They mean a small change. But dx 没有, don't have. I do use notation like this. It's okay. Because in this notation, I'm saying that I'm differentiating something with respect to x. It's okay. But I will never use dy by itself nor dx by itself. I don't. Likewise, for the integral sign, I will always have integral with a dx. Okay. The whole world knows. Very dedicated player. These are people who are very passionate, you know. Yeah. Okay. So example 1 is basic. As I told you before, if you think that math is not about memory work, no memory work is needed, it's a half truth, half truth. You need to memorize to be good at it. You really need to do some memory work. It's not entirely true that math doesn't need memory work. Okay, let's have Tingwei to walk around the room now, because she's distracted already. Okay, so as you're memorizing this list of formulae, here comes Tingwei.
Still can't tell what I did wrong.
Let me check. Oh, because when you differentiated, how do you differentiate this one? Should be quotient. Okay, you're right. It's -1, is it? I can't really see. I'm going to take a picture first. Then maybe I will actually know. Your handwriting is neat, but seriously, okay. Let me take a look.
I'm gonna submit this.
Okay, come. I previously told your score before, right? You all know your score, you know. But because everybody did quite well, so therefore we might not need to actually go through.
Therefore, we need to take a class.
Right.
Yeah.
Oh, I see a mistake again. It should be 3x squared. Right, 3x squared. Okay. I assume that you have already memorized the list of formulae. So therefore, if I say close your book, when I say close your book, I'm going to throw out a question and then see if you know the formula. You can do it, right? Yep. Okay. Instead of doing so, class, I'm going to ask you some other standard formulae. Do you know this formula? If you integrate something like this, let's hear from next to money is Zheng Hong. Zheng Hong, because you move yourself, so I caught my attention. Zheng Hong, what will this be? If you integrate something like this, do you know this formula?
What's that?
Integrating. For example, you need to integrate this. Okay, Zheng Hong. Okay, let's see if you can do it by substitution. However, you don't need actually, you don't need substitution, Let's hear from Zheng Hong. How would you use Formula 1? Wait, Money, you want to say it? How do you do this question? Okay, I'm going to ask you, Money, is this correct? Is this correct? Money says you need a. Why is that so? In order to use the Formula 1, right? You need to append a 2 and then a half, so that it becomes Formula 1. I hear Ryan in front here saying that you can use substitution, which is true, but it's an overkill actually. It's an overkill. The A-level students, they don't use substitution for such simple questions. They don't. they use Formula 1.
Because when we were first learning integration, we didn't really learn this as like a general formula sort of thing. So
Right.
most of the time whenever you see something like this, you just use something.
Right. So I'm here to help you to make the paradigm shift. You want to actually, you want to actually upgrade yourself. You used to be using substitution. Now I want to empower you, to do it without. Okay, there's another formula that goes like this. The whole world knows.
Oh, this one I know also.
The second formula is actually Formula 1 with n equals to -1. But when n is -1, Formula 1 doesn't work. Formula 1 doesn't allow n to be -1. And the case when n is -1 is taken care of in Formula 2.
What is another one?
Okay, Ethan, since you asked, you can tell me what is the answer, you're good.
I think I'm
Can, Ethan can. F prime over the square of fx. Let me read more carefully. Okay, Ethan, let's hear from you.
Yes. 2 square root f x
Right.
plus c.
It's a good formula to remember. Of course, some people say actually Formula 3 is already taken care of by Formula 1. It's true. You just put half in Formula 1, you got Formula 3. But because question 3 type, Formula 3 type occurs so often that I decided to lay this down as a third formula. Is it hard to remember 3 of them?
No, it is doable.
And do you know this one? I'm quite sure most people don't know this. You don't need to know this as formula. You can derive on the spot. So let me hear from. You say something, Aditi? Yeah. So because you subscribe to my ideology, now let's have Aditi to come to the front and tell us how would you have done this. Aditi, how? On the spot.
Square root or you know what?
没有。
No. Oh, okay. Then where's the?
I got square root.
I don't know this.
The duster is behind the screen. No, don't have. Then missing.
It's okay. Okay then.
The one?
Yeah.
No, it's not. It's simpler than what you think. It's simpler. I give a skeleton answer there. I give you a skeleton answer there. No. Should I give a hint? Okay, I give a hint in this manner. Let's see, you can try to see what this represents. Huh? Pink form. No. Go on. Jared, what do you think is PF? I'm sure you can guess what PF means.
Like in the end, it's negative 5.
Right, Jethro, you're right.
Jethro, not Jethro.
Jethro, is it?
Jethro, not Jethro.
Oh, sorry. Stephen, sorry, Stephen. Partial fractions. You want to be able to break this up into partial fractions like this. Well, Aditi is doing it. You want to guess the green color? It's on the screen. I give you some hint on the partial fraction. It's okay, Aditi, I'll take care of that. Thank you. It's okay. Now, hang it. This one will be. Actually, I'm right. Actually, I'm right.
Wait, but then how do you partial fraction it?
Okay, I'll tell you.
Magic,
Okay, I'll tell you. This line is right off, but Aditi actually put x as a, it won't be.
Oh.
Yeah.
Okay, never mind.
Okay, class, with the 5 in blue color, can someone guess 5 in green color? 5 in green color. Do you think you can write down the answer for 5 in green color? You can write down the board. What do you think is 5 in the green color? What may it be?
Just plug it into just now that one.
No. Don't go through partial fraction again. Just guess. Yes. Just guess. From the blue color formula, you want to give me the green color. Let's see who is very sharp, you know.
One over 4 b.
Anybody? Okay, no worry. Only I take care of that in a second. Okay, I'll do it. Thank you.
1 over b log a plus a.
1 over 4 b plus. Oh, yeah. Then a minus. Bx minus a. Then 1 over 4 b.
Yeah, I heard in the front here, it's quite correct, you know. They say about over B. Yeah. Good. Yeah, the front two were saying about over B. Yeah. Most people miss the B. What is it again? How do I get the green color or red color? How do I get this answer, is it? Okay, to get this, to prove that this is true, you really have to go through what Wendy was trying to do. She was trying to break the partial fractions, but it's quite tedious. So instead of doing it all over again,
Memorize.
thank you. Subscriber to my philosophy that math is not totally memory free, you know. Yo, say again. Oh, okay. Can take pictures. Can't see the top. Is it? Okay, like that can. Can I give one more and see if y'all can concrete? One more, okay? All of you are good at this formula, right now. All of you are good at this formula. I'm going to post one more, and let's tell me if you are able to write down. Can you guess the formula based on what you see here? When do you want to do a second try? Number 6, right? Number 6. My number 6. What do you think is number 6 going to be? Based on what you see here. Huh? Yeah, try. Yeah. Use a good blue marker in right here. What do you think it will be? Write bigly. Top left, write bigly. We are looking at this question, you know. Of course, it has to be this number 6. Oh, okay. Based on what you see there, you finish here. Just like okay, thank you. You need the 1 over b, and then of course plus c. She's almost there, almost right. So you need the 1 over b.
Yeah. For you divide everything.
Right.
Then it becomes 1 over a times a over b.
Right. So I want you to be able to actually remember the blue color because you know this basic one. And one last one.
So much of this being the last one. And then this one for tension is
Right.
This one for tension is
Last one, I will write for you.
1 over.
This one will be
1 over b again.
right. This one is a AB.
Oh yeah, because there's no rule.
Oh, not bad, no. Right, they're quite sharp.
Because I vaguely remember some stuff from last year.
Okay. So, class, I actually would like to encourage you to remember this 7. This is how the A-level students learn it. So they actually learn beyond the basic. They remember them. How do you remember things? It is by blood and sweat. Some people say you write this thing down on a piece of paper, burn it into ashes and drop it in the cup of water and drink the water. Yeah. Silly thoughts.
If you wish to get cancer, go ahead. Nobody's stopping you.
Okay, for those who are trying to memorize and already have memorized, I want to ask this question, you know.
Ding 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 ding.
Out the window. Next, please. There's a question I posed that I posed on the board. Okay, in case you can't see from the back, what I posed was this: integrating x. Okay. Give a sound that 30 seconds to think, and then after we echo together the answer. Okay.
3, 2, 1. Yeah.
陈辉，你可以吗？ Wow, he's right.
Wow.
He's able to think reverse. Okay, are you ready? Let's see if you have memorized. Okay.
One over four x plus
Some people say, Mr. Lin, this is silly to ask because they say, why can't I say this is actually the negative of the earlier one that we did, you know? It is true, no? It is true. Just now, if you look carefully, my A5 was a squared minus x squared. Now this x squared minus a squared. People would prefer to write the formula for this one like that instead of doing the red color. No? You know what I mean? It's just how people do it, the norm. Nothing stops you from doing like the red, you know. But people normally will keep the green as green and the blue as blue. Just now we had the blue, right? This one.
The thing I don't like about it is integration is how it can escalate in difficulty so quickly.
The truth is integration actually, you think about it, like, it's a no-brainer topic. Why no-brainer? Because the more remember, the better you are. Integration requires a lot of memory work. For example, offhand, I say integrating secant x. Let's say together the answer for integrating secant x. Okay, let's do it together. 1, 2, go. Integrating secant x. Say again. Integrating secant x is what? It's not, you know. You said long or not?
Wait, that is quite.
And the proof of this is not by substitution. The proof of this is formula 2. F prime x over fx. To prove this further, you use formula 2. Viresh is going to march the board and show you the proof. So I was saying, to prove this one, you need this formula. This one. Secant x is 1 over cosine x. No worry. Okay, no worries. So what people do is, they do this, no? Okay, give Viresh a bit of time. Right, multiply by. Right.
That's what I'm thinking. Let's say yes.
Just say yes, that's right. So by introducing this extra factor, things work. What worked? The formula on the top right corner works. So that's how people prove this formula. You know, integration, right? You just really have to memorize, no? And then you think that just because you know how to integrate secant x, if I ask you to integrate secant square x, right? You think you know, no? But it's not, you know. Right. And then integrating secant cube.
Oh my god.
Yes, it's by parts. Right, it's by parts. Yeah, secant cube is to be done by parts. Yeah, it's quite tedious, secant cube. If I ask you to integrate this,
Just like changing the power, it escalates very tedious.
right, this double angle. If I ask you to integrate this one, it's true. Substitution is the recommended method, but now I want to challenge the class though. Can we do this question without substitution? Oh, Viresh is going to show us. Is can we do this question without substitution? Huh? No. Because time is going to be up, I better write down for you.
Oh my god.
What?
So I'm trying to impress on you that sometimes it's easier than what you think.